Greetings. So today I have created a semantic search engine. So what a semantic search engine does is it does not look only at the keywords of the query but also looks at the contextual meaning behind the query. So let me walk you through the code first. So we'll be using various libraries from LangChain. We will be using OpenAI's LLM model. We will be also using vector database Pinecone, and for the UI and the website we will be using Streamlit. So first I have set the page configuration along with the title and icon. And next, I have given about the page in the sidebar. Next, here is a clear submit button. So what it does is basically is whenever the query is removed, query is changed, or the file is removed or changed, then it will set its session state to false. Next, we have the set OpenAI API key function. So whenever the user enters the API key, it will store it into a session state. Next, we have the extract text function. So the user has a choice to upload three types of file, either PDF or document or the TXT file. So based on the file extension, it will extract all the text from those files. Next, we have our vectors function. So what it does basically is it will convert all the text into vectors and store it on Pinecone, the vector database. So first, the text is split using recursive character text splitter into chunk size of 1500 characters with no overlapping. Next, we initialize our Pinecone's API key and environment. After that, we initialize our embeddings using OpenAI embeddings, and then we set up the Pinecone by passing the API key and environment. After that, for all the text, we embed it into vectors and store it on to Pinecone in the index name semantic search, which I have created on Pinecone. And we'll be using doc search to reference to that vector database. After that, I have initialized LLM, which is basically the LLM model of OpenAI, and have set the temperature to 0 so that we get precise answers. Next, I have just initialized the chain, which is load question and answer chain, by passing the LLM model, and have kept the chain type to stuff. Next, we have our find answer function. So the query entered by the user will be sent to Pinecone, and similarity search will be performed so that we get all the relevant documents. Those relevant documents will then be passed to the LLM model along with the query so that from those documents we can get a final answer. After that, here we have a sidebar of text input where the user can enter their OpenAI API key. And if they don't have an API key, so I have given a help so that they can go to OpenAI's platform and can get their API key. After that, we have a file uploader function. So the user can upload their file through this uploaded file function. And after that, we are sending that uploaded file to extract all the text and initializing the vector database and chain. Next, we have a question is equal to st.text area. So this is a text area where user can enter their query, and I have given some styling to it so that the font size is little more bigger. Next, we have our button. So whenever the user clicks on the button, it will check if the size of the query is greater than equal to 5 to ensure that user has written some query. And it will also check if OpenAI's API key has been entered. If has been entered, then find answer function would be executed and the final answer would be displayed. So now let's see the working of it. So here I will upload a research paper on artificial neural networks, and I will also paste my OpenAI's API key. Next, I will ask in the text area that what are artificial neural networks, and click on submit. So finding the most precise answer, and here we have our answer. Artificial neural networks are relatively crude electronic models based on neural structure of the brain and so on. So as you can see, using Pinecone, we have optimized the search a lot, And also, along with that, I have added the caching technique, the cache data and cache resources feature of Streamlit to optimize the search further. So this was my project of semantic search engine. Thanks for watching.